I am sitting in one of the best institutes in the country, ranked one in many ways. If I can't build a deep tech project here, I can never do it in my life. So I think we will be launching 6 to 8 satellites after this first one in the next 4 to 5 years. India space, in my opinion, walked so far, and we will now run.
Hi, my name is Amrit. We've heard that IIT Madras is the best place to build. So we've come down to the Sudan Shankar Innovation Hub. We want to meet some people. These are builders. We want to talk to them about their work and also ask them what makes IIT Madras the best place to build. Hi, hello, and welcome to the Best Place to Build podcast. Today we are sitting with Suyash Singh. He's the co-founder and CEO of GalaxEye, one of India's hottest space startups. Hi, Suyash. Welcome to the podcast.
Hey, Amrut, thanks for having me.
Suyash, the first thing that I've noticed about you, and I've met you a couple of times by now, is that you're always smiling. It's amazing. I also want to say that I can imagine how difficult, stressful you must be at because you're running a space startup in a country like India. What is the secret of your smile?
So there's a nice story to that. So when I was at IIT Madras, I was starting this team called Avishkar Hyperloop, and our first orientation session, all the guys came in, and when I was finished with the presentation, they said, "You are super depressing. We don't feel that we should be working with you." And that was the point, I started to practice smiling slowly, and gradually it became a part of my life. Yeah.
That's amazing. You were at IIT Madras which years?
2017 to 2019, I did my master's.
So what is the story? How did you get here? Where did you study school from? And just run us through your journey to IIT Madras.
Sure. So I did my bachelor's back in 2013. So I graduated in 2013 as a mechanical engineer. Then I did a corporate stint, where I did a bunch of other things. I experimented throughout the life. I prepared for UPSC. I did a bunch of other things as well during those 4 years. And eventually at TCS Research, where I used to work, I found myself not having a lot of good fundamentals to engineering and life. So, that was the point where I decided to kind of pursue masters at some university here and there. And of course, gate examination was the gateway to IIT Madras. And that by appearing to that, I made it to IIT Madras, joined aerospace engineering here. And after joining here, my goal was to kind of get, hired by one of those big giants like Amazon, Google, Facebook, etc., Netflix. But, eventually ended up doing deep tech, building Hyperloop for next 2 years, building a massive good team. And that was a U-turn entirely, right? From mechanical engineer to doing Hadoop, AI, big data in 4 years, appearing for UPSC, coming to IIT Madras and doing deep tech, and then doing deep tech forever.
Damn interesting. Just a stop, little bit of information gap I have here in the sense that I'm not very clear about how the gate exam works. I also find it a little odd that see in JEE when students go from class 12 to college, they have no idea about life anyway. So it's fine. Like one exam bunches them into a bunch of courses. But after you do your bachelor's, you work for a few years, you're giving the gate exam. Isn't it weird to have one exam for computer science, mechanical engineering, aerospace? These are completely diverged fields by now, right? So how does that work?
Well, so I think there are specific papers for each of the engineering disciplines, right? So you don't give a generic exam for all the engineering discipline. You have to specialize in that particular discipline that you have done your bachelor's in. But all the more, I do agree partially that it's a very very short exam for what you've learned for 4 years. and testing the aptitude for engineering in those 2 to 3 hours is little unfair to many, so to say, right? So I myself attempted it for 2 times, got into the second time.
Okay. And then did you choose to join aerospace? Was that something that you wanted to do?
Partially yes, and partially no as well. I was more focused on getting into a discipline where I can build on applications, and I'm more application centric person rather than going deeper into research and so on and so forth. So my master's for me was to kind of pick one domain and become an expert to that particular area as much as possible.
That's interesting because when you're doing a master's at an institute like IIT, you have the option to sort of go more into research side.
Yeah.
Yeah. Or more into application side. So then at IITM, you joined Professor Satya. But in addition, you also started the Hyperloop Club, right? So what is your experience in IIT Madras like?
No, I think the goal was to kind of of course join aerospace. Professor Satya didn't was not the start point for me for my masters. It was a generic course for an year. In the second year, you get to choose your professor. Who do you want to work with for the thesis part and etc. When I met Professor Satya, it was a story. By that time, I was always already fascinated by Elon Musk and his competition that was organized at SpaceX every year. And by the time I was about to start my research, I've already latched on to kind of, doing Hyperloop.
I've heard the story before. So the way I've heard you say it is that you were in your first year masters,
Right.
and you heard about the SpaceX competition, and you sort of like couldn't sleep overnight because you were.
Yeah.
So can you run us through that?
Yeah. So I think it's an interesting story, 2 to 3 months, because I've given a gate examination, but, I also worked for a corporate for 4 years. So my lethargy to going classes and other things were actually pretty much than other students who came in the batch. So it was almost difficult for me to sleep at on time and get up on time and do things. So I used to kind of speak to my friends who are in the US and so on and so forth. So one of my friends told me that Elon Musk has started this competition where they get to build Hyperloop and they get to demonstrate it at SpaceX. And that was the moment that hit me very hard. It it was like I am sitting in one of the best institutes in the country, ranked one in many ways. If I can't build a deep tech project here, I can never do it in my life. And that triggered me very, very hard. And the other motivation was one of my friends said, you can't do this in India. So, it became almost like, I want to kind of give it back to him, speak back to him, saying that, this is how I built it and I built it better than your university in the US. And that's how it started. Couldn't sleep overnight, of course, and the next day um, went to a bunch of people who can actually join me for this crazy thought process. Because generally, you'll find in the institute when I joined in, there was a cultural divide between bachelor's and master student. And it was way easier for a bachelor student to kind of walk into CFI, Center for Innovation, and start something. While masters don't have that culture, right? So from seniors, there's no rolling culture that was coming to us during our master's time. It was challenging, to be honest, to kind of walk into CFI or walk into anywhere. First of all, find CFI that there is a there is a center for innovation to do something like that. But I was curious enough. I went to many of the events and uh, discussions that were happening in the institute that time. And I found Gaurav Lodha was in 2017. And I spoke to him. I kind of, uh, I was chasing him in many of the places in the labs here and there, wherever he could go. And I found him one day. I wrote an email to him and he agreed to me saying, okay, you're a master student. I don't know how far you will go along building this project, but let me give it a shot. I will go to my dean and ask whether I should be allowing you to build a team here or not, but let me give it a shot. So he took a leap of faith and he said, let's try, but don't ask any money. Like, I won't give you any money at all. But he putting some faith in a person who is coming from masters, zero cultural alignment with the bachelors at that particular point, in my opinion, was something that was pretty massive as a trust.
This is interesting. What you're saying is you heard of this project, international project. You were deeply motivated to go and try.
Yeah.
Nobody is trying Hyperloop in IIT Madras or in India,
India largely.
right? And so you go to someone,
Yeah.
and say, "Hey, listen, let me build a Hyperloop club,
Right.
or a Hyperloop project."
Yeah.
That can go two ways, right? Somebody can just laugh at you, and somebody can say, "Okay, sure, why not?" Right? So you're saying that somebody chose to do the so this masters BTech divide, I guess it's been there for a while. It's changing now.
I think after we building Hyperloop and keeping that mix of master students and bachelor students together in the same team, giving that example to many that this can work very nicely. Plus, master students bring in that research kind of mindset, while the bachelor's people would bring in that innovative mindset. And when these two things come together, I think Hyperloop kind of projects can be pulled off.
Right.
And when that was demonstrated, I think post that we have seen, it has become better. So we generally call ourselves as the bridge between bachelors and masters. That, we bridged the gap at that particular point of time. And we have seen many other teams also kind of doing the same thing after that.
Interesting. You know, I also imagine that master students are probably closer to professors because they're research associates, or and they've come here with the intent to join a professor's lab or something like that. Whereas bachelor students are still fresh and amazing. So so you got here, and then of course you graduated. Did you from starting Hyperloop? Did you imagine that would lead to your journey to GalaxEye?
Honestly, no. So I still vaguely remember when we were starting Hyperloop. Uh, we used to, our professor who used to guide was Professor Satya, and he's still guiding the team, by the way. He also started a company called Agnikul in the same lab that year, right? And that was very space focused. They wanted to build launch vehicle, etc. We were building Hyperloop. We started Hyperloop. Agnikul was starting up exactly at the same time in NCCRD that time. But I was never fascinated about space that time. So post my 2019, when I graduated, I happened to get an offer from two of the biggest corporate houses in the country, right? So I chose to go in one of those, while my other teammates went in the other corporate house. I won't take the name as of now, but the the place where I went to work got me into starting GalaxEye. Yeah, so space was never a choice, or never an interest to me to kind of get into, but it happened because a very interesting problem statement came my way.
Okay.
Yeah.
Very interesting. So then you got back, and you know, I have a sense of what GalaxEye does, but it'll be nice to hear it from your words. So what does GalaxEye do?
So think of GalaxEye, you know, it's a space technology startup vaguely, but let me tell you in the other way. We are a data company. We acquire data from space. We click pictures from space in the most layman language, to be very honest, right? And what do we do and why do we do is, if you think about the larger gamut of space applications here and there is communications, navigation, and imaging. These are the three large applications in space. Communication and navigation, in our opinion, is pretty much done. Imaging is something that is not yet done at that scale. And one of the key reasons to that is the cloud cover that Earth has all the time. So at any given point in time, Earth is covered by clouds around 70%. So 70% of the landmass is covered by clouds. And during the night time, your cameras can't open the shutter and click pictures because you don't have enough light. There's no source of light during the night time, and clouds can't be penetrated by the visible cameras and stuff. So I think this problem statement was very interesting for us to, to see whether we can build a satellite that sees through the cloud and still give you an imagery throughout the year, agnostic of the cloud, agnostic of the night time as well. And that started with an interesting problem actually. It didn't came out so well in the beginning. It started with I was solving for a California forest fire problem, wherein I had to quantify the damage of how much forest has been damaged by the fire. And while doing so, my natural progression was to kind of collect satellite imagery. And I did that. When I took satellite imagery, it was all smoky or cloudy. So can't see
So
through.
1 second.
Yeah.
What do you mean by take satellite imagery? Who gives you satellite imagery?
So I think by that time in 2021, there are a bunch of space agencies who have already launched Earth observation satellites of A kind and B kinds. And there are a bunch of companies as well, who are based in the US and Europe who operate those satellites. Okay. And they collect data. Okay. So what we found that in all of these satellites that existed in 2020-21 time frame, it was either a camera-like satellite which would click pictures, or it will be a radar-like satellite. Okay. Now radar is something that penetrates through clouds and can do nighttime imaging, but it is like X-ray. You see black and white dots in that. So either you find a camera-like imagery or a radar-like imagery. Both are not useful because camera is intuitive but not available because of clouds. Now radar is available but not intuitive.
Right.
It's
Because
like an X-ray.
I'll have to sort of train myself to read that.
Absolutely.
Yeah.
So we wanted to kind of come to a midway between these two, and that make imagery available and understandable for an average user. So, for example, if I am in my final year of my graduation and I want to solve for an agriculture business or for an aquaculture use case, or I have any problem set that I want to kind of solve for, and that can be done by satellite imagery, today it may not be very much possible because the consistency in satellite imagery is not there. Okay. So, service level agreement that we call generally is that to deliver a satellite imagery with clear, visible, no cloud cover into your inbox, and that you use for your SaaS automated application. That is not there.
I'm imagining that if I want images of, say of this building, we are sitting in the CFI building, so I want space imagery of this building.
Yeah.
And if there is a cloud cover at a particular point, then the satellite has to basically like wait for the clouds to move or like do a full orbit and come back, and
That's right.
hopefully the clouds will be gone by then. Then
Yeah.
it not take another orbit and come back.
So it's unpredictable.
Okay. So you mentioned, so the way you started was you said that the use cases of space, I don't know what is the word you use, but it's navigation, communication and imagery imaging. So navigation is like GPS,
Right.
communication is like cell phone and
Right.
internet. And so I'm just trying to understand what is imaging used for today. And I know you said agriculture and aquaculture use cases, but what does that mean?
Sure. So I think imagery is used in, I would say, 4 bigger, larger buckets, so to say, right? The first bucket is mapping and surveying. So you're planning to put up a building somewhere, or you're planning to put an infrastructure somewhere. Then you acquire these imageries and you find places and you properly plan on that. You use the dimension scale, whatever scale, you plan the entire layout. So that's called mapping and surveying. Second part is on the commodities monitoring. So if you see, we're one of the largest agriculture geographies in the world. So rice, wheat, maize, corn, potatoes, tomatoes, onion, shrimp, which is an aqua commodity, spices, coffee, palm trees. All of these are like
Wait, hold on. You are saying that with space Earth imagery,
right.
somebody will be able to tell how many plants are how many acres are under wheat cultivation? How many acres under?
Yeah, you can do that. So it's basically your commodities monitoring. Okay, and I think the imagery has been unlocked and exploited to a level that you can do crop classification. You can not just do crop classification, but you can also tell the health of the crop. Okay. Yeah, and largely, it's used for supply intelligence. So, for example, you're an exporter and you want to know how much rice has been cultivated at this particular point, and can I take all that rice and sell it wherever you want. So you get that supply intelligence. You know the quality of the rice from where you're procuring from. One of the interesting use cases is, let's say you are setting up a biofuels plant. Suppose you want to produce a megawatt of energy every day, but you don't know from where to procure the agri waste. So your supply has to be consistent to produce 1 megawatt of energy every day. So for all of these commodities monitoring, satellite imagery will be super and massively useful. And then the third is, which I think, which is very proven use case, which is defense and intelligence.
Okay.
You kind of go around, you see, you monitor the borders, you detect the changes that is happening around the borders, around your adversaries, and so on and so forth. So it's a dual use application, and most of the satellites are like that. All the applications from space will generally be dual use.
Okay. Dual use as in military use and civilian use. Yeah. And in the civilian use, there is maps and navigation. And what was the second?
Mapping and surveying.
Oh, mapping and surveying. Sorry.
Yeah, mapping and surveying. And second is the commodities monitoring.
Okay.
Yeah.
You said 4 things: mapping and surveying, commodities monitoring, defense, and
Intelligence.
And intelligence.
And there's another thing, which is asset monitoring.
Okay. Asset.
Yeah, asset monitoring is something, like transmission lines, and you want to monitor the encroachment. So by the way, Hyperverge, one of the other IIT Madras companies, they had this interesting solution to monitor all the transmission lines and understand what is the encroachment that is happening, so that the transmission tower is away from the right of way corridor, from any of the greeneries, that is.
Oh, we are talking about the really tall transmission
towers. Yeah. So maintenance and other things, when you do at scale, flying drones to hundreds and thousands of kilometers for transmission lines becomes tough. While drone give you much finer details, satellite gives you that like first cut analysis that here is the vegetation going prone at this point.
Nice. So GalaxEye does Earth imaging. You use that data to build intelligence on it, and I know that you have a SAR technology. Can you just explain that technology?
Sure. So the 4 use cases or the large buckets that I talked about, right? Mapping to commodities monitoring to asset monitoring and defense and intelligence, right? Now, all of these things, I feel some 100 applications can be built on top of these.
Okay.
Like each domain, one application. Railways monitoring, one SaaS application. Road monitoring, one SaaS application, and so on and so forth. But we found a gap. This is not happening for one small reason. That's called the inconsistent behavior of satellite imagery acquisition. Okay, right. So all these SaaS applications that we're talking about for commodities or railways monitoring or so on and so forth needs consistent imagery inputs. That was not available. So that's where we came down to saying, what kind of technology can help us acquire this data consistently over the time? And that's where we found synthetic aperture radar and multispectral camera as a technology coming together can help bridging that consistency gap.
Okay. So, okay, I understand at a business level what you're saying.
Sure.
But at the technology level, what is what can you break down each word for me?
Sure. So SAR is synthetic aperture radar. SAR is a technology that is a microwave that does imaging in the microwave spectrum of the electromagnetic spectrum. Now, there are many bands that you can use. You can use an L band, you can use a C band, you can use an X band, P band, and so on and so forth. All of these bands are also used in some sort of communication as well, right? But we use these bands for imaging.
Okay.
So, for example, X band generally ranges between 9 to 10 gigahertz, right? While L band is on the lower side, right? So, high frequency towards, if you go towards high frequency, that's X band. If you go towards lower frequencies, you go towards L band. Now, the lower the frequency is, higher the penetration is. Okay. So, for example, you want to penetrate through a foliage cover, the forest cover, and see what is hiding beneath the forest. Then you need an L band SAR. While the X band SAR is very good to understand the buildings or the urban footprint that is available on Earth. That's at something around 9 to 10 gigahertz. And uh, above X comes KU, KA bands and others. But KU and KA sometimes don't penetrate through clouds very well. But X onwards, you do that.
Okay. So this is what you mean by multispectral. Like you are.
No, multispectral is a different region altogether. So that comes in visible and IR side of the story. So in the EM spectrum, if you just draw that, we use microwave region, and microwave has certain frequencies in itself. So you exploit each of the frequency for different application. While visible and IR range or visible and infrared range, that is what is used for imaging like a camera.
Right. That's the more visible side of
Yeah. So you capture red, green, blue, and other bands in the visible range. And there's a band called near infrared. So it's like somewhere between visible and IR spectrum, somewhere in the mid. So multispectral and hyperspectral cameras that we talk very often talks about visible and near infrared ranges.
So there's IR, near IR, visible, and then there's microwave. In microwave, there's L going on to X and then K,
on and so forth. Yeah.
Okay. So the SR technology is on the microwave side, and the multispectral technology is in the near IR and
This visible side. Absolutely.
And so your technology marries the data from these two things and gives you an interpretation.
Absolutely.
So technically, you can sort of like use it to see beyond cloud cover or below what is below trees.
Yeah.
And
So it's the more better way to interpret or think about it is visible in IR ranges, or I would say visible more or less, is more dependent on sunlight or light source. While microwave is not at all dependent on any light source. So you have your own source to kind of trigger a particular element. So you send your own signal.
Right. Of course.
Light it up, get that image back.
Right.
So when you don't have sun, you use microwave. And when you have light source, you use visible. But this microwave also has a capability to penetrate through cloud cover and so on and so forth. So marrying these two actually have its own benefits of making it more available and understandable.
Nice. Damn cool. So broadly, I understand this. And is this like if I go back 20 years, GPS was just being available for commercial use, and maybe some people in the industry saw it, but the common person or even as an engineering student, I didn't understand that this would mean that we will have Google Maps and we will have Uber, Ola, or Swiggy, which is all enabled on top of Google Maps, or at least they're more efficient because of Google Maps or other maps. Not to mention that only Google has maps. Is that do you see that happening? Do you see that consistent imaging layer enabling a bunch of startups or bunch of companies to bring in technologies that will impact all of us?
Yeah, I think that's the idea. That's the premise of building GalaxEye, to be honest, right? A nice analogy to that is when GPS came down to an accuracy of 5 meters around the 1998 time frame, we saw GPS coming down and becoming, those micro instruments that can go on a bus, where people can track the bus, where people can track the car. And then eventually it came down to maps. Eventually it came down to delivering literally everything at our house. At our houses now.
Yeah, I mean, I have every day in the morning, I have to put my daughter on a bus. I am constantly checking where the bus is on maps, and it's a very important start of the day routine for me.
Absolutely. In fact, you start with e-commerce, right? E-commerce was a courier service in the beginning.
Yeah.
It became a GPS-enabled tech at a later stage.
Yeah.
Quick commerce can only happen because this is.
Yeah.
So e-commerce to quick commerce
the
to whatever
quick,
commerce.
the quick part of it is
So all of these things were enabled by GPS. I think the similar enablement with imagery to such a gamut of applications are yet to be unlocked.
right.
And that's precisely what GalaxEye wants to kind of nail down.
So you mentioned that your first satellite is going up in space, and I'm thinking that in the case of NASA or ISRO launching a satellite, they've launched hundreds of satellites. So it's for them it's one incremental step, but for you it'll be your first step, right? So you go from 0 satellites to one satellite. How does an engineering team sort of manage that? What are the risks involved? Run us through that.
Sure. So our first mission, so every satellite is a mission to us. Not just for us, but even for NASA's and ISRO's and ESA's of the world. Now, this mission that we are calling is called Drishti. So, like, Drishti is like you see through it and you have to catch everything. So, Drishti mission started when we started GalaxEye around 2021, December. Uh, I think there's a bunch of playbooks. So, there's a very interesting book by NASA called Systems Engineering. And it's free ebook. You can always download it from anywhere. And, that defines few of the steps in a framework. So you need to understand what you want to achieve from space, which is basically the idea. Then you convert that idea into some sort of concept. For example, for us, that idea of consistent behavior of satellite imaging became a concept of multispectral and SAR coming together on the same satellite. Now, from concept, then you figure out a preliminary design. Now, preliminary design is something, where you say that my satellite would look like this. It will weigh like this. It will take this much power. So, like you do a mass budget estimation, power estimation, you do a volumetric estimation.
Just for my understanding, how heavy is the satellite?
This satellite is going to be around 150 kgs, 148. Yeah.
And how big will it be?
It'll be think of a 1 meter cube.
Okay.
Yeah. It's like a mini.
So the size of this table.
Absolutely. Yeah. But it will unfold itself into a bigger antenna also, by the way. So it will be a 3.5 meter antenna with this cube there. So it's a pretty big satellite in that sense. So, yeah. So you come from idea of consistent behavior of the satellite imagery to concept of multispectral and SAR coming together to a first level look and feel of the satellite. Then you go into components, Then from PDR, preliminary design review, do you go to a comprehensive or, complete design review, which is called CDR. Now, PDR to CDR is the massive job that you do. You have to figure out the supply chain. You have to figure out who will give you the ICs, who will give you the antenna panels, who will give you the solar panels, who will give you the solar cells, who will give you the control systems, who will give you the star sensor, who will give you the star tracker, give the batteries, who will give you the avionics, and a bunch of things come together. And satellite system is almost like a mini car system. Of course, there are like millions of parts are not going inside, but there's still like some hundreds of parts which is going inside, and that has to work in tandem.
Also, you can't fail, right? You can't launch and then figure out that some component is not failing. So how do you take that risk?
So post CDR, which is comprehensive design review, right? You do all the simulations in place. You probably go about taking some risks and you avoid some risks. Like you avoid some risks by saying, I will take a component from a company which has proven it already in space.
Okay.
So, there's a space proven component that you take. So that will not fail. But with some, you take the risk now because you're innovating, right?
Is there that supply chain available in India?
Yes, partially. The other part we have to procure from out.
Okay.
Partially because it is going to increase a lot because ISRO traditionally have developed that entire supply chain in India by building Chandrayaan and all these satellites already.
Okay.
So it's already non-existent.
Yeah, so there are already vendors who have supplied to ISRO and so on. Okay.
Yeah, so it is there, but it needs to kind of innovate a little more moving further. Right? So precisely to your question, post CDR, you need to test out all of these things in a space environment or space equivalent environment. So you need to put that in a thermo vacuum chamber and heat it up as much as possible. Still perform your code execution, still perform your imaging. You open the shutter of the camera inside a thermovac chamber, and you have to put it on a vibration chamber and vibrate it, because launch vehicle when go like this huge combustion that happens. So it just like goes like this, right? So you have to put it in a vibration chamber to test it out in a space environment. So idea to concept to PDR to CDR, then you do an AIT, assembly, integration and testing. And then finally you are launch ready. So there are several steps and it takes some time. So for the first time, as you said, from zero to no, zero to one, that journey, you have to learn as well. You have to establish a supply chain. You have to do a bunch of other things. So it took us around 3.5 years, to be honest, to figure out all of these nitty gritties. Okay, and optimize the risks where you want to take the risk and where you don't want to take the risk.
Right.
Yeah.
I read about something called Poem on your website. What is that?
So it is one form of testing, right? Now, Mission Drishti is 8 to 12 months away from now. And we have crossed most of these stages. So we're in the final phases of our satellite. So ISRO gives you an opportunity to not just test on ground, but they have a module at the final stage on the launch vehicle that they have, where you can put a couple of subsystems or one subsystem, and with their existing launches, they take that experimental module and puts that into space. And they let you perform whatever you want to perform into space. So one of the critical systems in our satellite, we thought, let us put that into that experimental module. It's also called POEM. Now, POEM is nothing but PSLV Orbiter Experimental Module.
Okay.
Yeah. So you put that on a POEM, you perform those experimentations, get the result back, and validate what you're thinking or course correct. So POEM is a way to kind of test out few of the things onto that module before even you launch the real satellite. Right? So in fact, POEM is supposed to kind of go into the orbit on 26th December to 30th December timeframe this year. So we were excited. That just didn't give us peek into our final testing of the satellite. It also helped us, the team, to go and touch the launch vehicle, to kind of feel how does one satellite goes and sits on a launch vehicle. Learn end-to-end launch activities.
So it feels like it's not exactly 0 to 1, but it's like there are a lot of like 0.1, 0.2, 0.3. It's like lots of step in between.
Yeah, it's not binary.
Okay. Damn interesting. So in this epic journey of yours to go from just thinking about this is the problem I want to solve, which is consistent Earth imagery,
right,
to having, I'm guessing you have multiple satellites, right? You'll have a set of satellites,
right? So now that we, post the launch of this first Drishti mission, we would like to replicate this Drishti mission into many more satellites. And hence you will have a network or a mesh of these satellites around the Earth, which gives you more, more timely images, more revisits on a particular point on Earth, and gives you more denser imagery collection capability. So I think we will be launching 6 to 8 satellites after this first one in the next 4 to 5 years.
Amazing. And since we are talking of Earth imaging, I did this thing where I checked out the history of Earth imaging.
Sure.
So I want to show you. So I guess you've already seen this. I don't know why I'll show you. This is the first image of Earth taken from space, and this is from an experiment run by a bunch of scientists on a V2 rocket in 1946. V2 rocket is captured from Germany after the end of the war.
Yeah.
So interesting. And of course, it doesn't show much. It's super grainy.
Yeah.
Move to the really famous image of Earthrise, which is from the Apollo mission. The first image, it's not the first image of Earth being captured from space, but it's a very like iconic image, right?
Yeah, much more high resolution and much better representation of Earth, so to say.
Yeah, and just the idea of like seeing Earth rise, like how we see moon rise from Earth. And in our prep call, you showed me an image which is absolutely fascinating. So going from this really grainy image in 1946 to this image, like, can you tell us about this image?
Yeah, so this is, I think, you can just see this image and see where Earth observation has come, where Earth imaging has come down to, right? This is Burj Khalifa's image, and this has been taken by a company, very famous company in the US called Maxar. Now, their tech is to kind of take 30 centimeter resolution imagery from space.
What does it mean, 30 centimeter resolution?
So, for example, this table, if you see,
It's about a meter.
it's about a meter. Now, if this meter cross that meter, let's say there's a square box, if that is 1 pixel in your image, that's called 1 meter resolution.
Okay.
So the finer I can see from space is the resolution that calls about. For example, this mug would be
10 centimeter.
10 centimeter.
Yeah.
So if my 10 centimeter pixel is there in my image, I can probably see the spot. Actually, it takes 4 pixels to classify an object, to be very precise. So I need this mug to be on at least 4 pixels, spread it across 4 pixels.
Right.
Yeah.
So if my pixel grid is such that from pixel to pixel is 10 centimeters, then it's a 10 centimeter
Image.
resolution.
That's right.
Yeah. So this is a 30 centimeter resolution image, and I can clearly make out like the bottom of the swimming pool, and
Right.
I can make out some cars moving, and it's amazing. So this is where, and this is, you're saying from Maxa. I think you mentioned earlier that you were getting images from some companies. Maxa, like one of the larger imaging companies.
Yeah, so I think we were getting from many other companies at that particular point of time, but this not just Maxa, there are a bunch of other companies who are existing and who have been very successful in delivering very high resolution optical imagery and very high resolution SAR imagery.
Okay.
So I think we have come to a stage where imageries can be made available.
So I'm confused here. So is your company buying the images and then providing intelligence on top of it, or do you have your own satellites? Or
We have our own satellite.
okay.
So what we understood is there are a bunch of companies in the market who are only doing optical.
Okay.
And there are a bunch of companies who are only doing SAR.
Okay.
But marrying these two together is the way future,
Right.
in our way. And no satellite is doing that.
Okay.
So that is our satellite that is going to come together. And that's the disruption in the Earth observation space that we are going to make.
Okay. Great. So like in software terms, I can think of it like a full stack imaging company.
Nice.
Damn cool. You also showed me this other image, so let's just go through that also. This is from an ISRO satellite, right?
Yeah. So this is Cartosat 2 series, and this is a Holker Stadium in Indore. So that was taken on January 15th, I think, which is also mentioned there. But you can see clearly this was also a 0.28 meters, which is 28 centimeter imagery. So India has gone down to 28 centimeter imagery, and you'll be very surprised that till 2020 we didn't have a space policy. We didn't have a geospatial policy.
Wait, hold on. Yeah. Before you get there, I have to tell you the story, and I want to explore the sort of the brief history of Indian space from the imaging side. When my daughter was born, such a silly story. When my daughter was born, our gynecologist and her, I mean, there were two doctors.
Yeah.
One of the doctors was named Insect.
Oh, really?
Yes. And she was very open about it. She's like, my father loved space. So, and it's such a popular thing, right? Like the Indian space program, the ISRO and the space program. So it's so inspirational and just like extremely like how do I say it? Like it's imbibed into our pop culture that we have this great space program, and India is one of the countries which has a great space program. So run us through from early INSAT days to this Cartosat 28 centimeter resolution thing.
Sure. So I think, if you talk about India space in particular, we are one of the 4 spacefaring nations in the world, right? And the spacefaring nation being one of those 4 means a lot, to be honest. And all credits to ISRO for doing that with great, great pride, to be honest. So we have one of the best launch vehicles in the world, right? Until SpaceX came into the party, probably our launch vehicle was one of the best in the world. And now, of course, SpaceX has done great things and so on and so forth. But launch vehicle wise, we were the best. Moving forward, we built so many satellites from imaging perspective, from telecom perspective, and so on and so forth. From INSAT to Cartosat to RISAT, IRS, EOS, I think we have built high resolution satellites one at a time, and that was built all by indigenously. It was all built in India. So I think ISRO was not an organization that was dependent on, the Western nations to kind of provide the technology transfer.
And almost bound because we were sanctioned in the middle and we had to develop it on our own, right?
Yeah, so it was actually, that hunger to kind of develop space technology was pretty massive, and hence ISRO has made a lot of strides so far. But typically, the most landmark moment that I feel is the Chandrayaan. Like landing it on the south pole of the moon was crazy. And if you see chairman's interview, it was not even, the landing was about to happen and chairman was so confident that it will land no matter what happens.
Yeah.
Even if we break the communication, we are landing, don't worry.
Yeah, it's remarkable. I mean, from very early on, we had a space program. It's
Yeah.
not like it's not like it's a post 1991 thing.
Right.
I had it from very early on. It survived on very little money, and it's remarkable.
Yeah, we have made great strides. I think we have made one of the best launch vehicles. We have made great moon rovers. We've also made great satellites. But I think there's upstream to the entire space ecosystem where you build hardwares. And there's midstream to this entire space ecosystem where you build infrastructure to gather data. And then there's downstream to this entire space ecosystem where you use data.
Right.
Right? We are great in upstream because of ISRO. Midstream, we were okay, but I think downstream, we were never there. What has happened of late is government came with this policy to kind of do reforms in the space and privatize space.
This is the 2020 moment.
2020 moment.
Okay.
Right?
And 2020 moment in space. Please tell us.
So 2020 moment basically said, it is open to private companies. You come, you build your own satellite. You build many applications on top of it. There'll be a policy that will govern, but it is very industry friendly policy, to be honest. So I think that was a pivotal moment for so much of interest that's happening in the space today.
Okay.
And India space, in my opinion, walked so far, and we will now run.
Very interesting. And of course, since 2020 to now, I think there are about 50 odd startups already.
83 registered.
83 registered space startups. Amazing. Okay. So we discussed sort of a little bit of history of imaging, the tech that you built, what it can do, and of course you are almost on this sort of this epic journey, right?
Yeah.
And can you I've heard that you have a take on how you want to get through that journey. So can you run us through how you're planning to get to space and use this technology?
Sure. So I think we started 2021. 2021, when we started with this problem to impart consistency in the satellite imagery world, caught us into thinking, how do we reach space and start this entire revolution, so to say. We are based in India. Our mindset is very Indian. So we are frugal. And building a satellite and putting it into orbit, it's almost like running a code that can be buggy and that code will fail on production servers. So we didn't do that at all. we said, can we actually miniaturize this entire technology that we want to send it to space and put it on aerial platforms such as drones, aircrafts, or HAPS. So in the last 3 years, we built sensor stacks for all of these aerial platforms. We did 400 plus flights on the same, gathered data, perfected the algorithms, architectures, and everything. And now the final moment has come that we are planning to go to space.
Okay.
So we are probably 10 to 12 months away when we start to orbit in space.
Nice. Damn cool. And I saw that you're going to space on SpaceX rocket, right?
Yeah.
That's an interesting callback because you started from Elon Musk's call to action almost, and now you are going to space with a Muskian rocket. In fact, just talk to me through it. Like, I know that in Hyperloop, and we can talk a little bit about the Hyperloop technology also, but in the Hyperloop SpaceX competition, you ran this team. Your team went to meet Musk. I fine. You had a conversation with him. But just tell me, why is Elon Musk revered so much in the space circles, and why is he such a inspirational figure for engineers?
I think, see, traditionally, space was always a subject of national importance earlier, right? Earlier to when Elon Musk really ventured with his SpaceX.
It was a NASA thing,
Yeah, it was always a NASA thing or an ISRO thing, right? Or any space agency thing.
ESA and
ESA and so on. JAXA from Japan.
or Russia.
Yeah.
Yeah.
Glav Cosmos. But, when Elon entered into this entire thing, he fundamentally asked a lot of questions at every stage of this entire, technology, how it was evolving, right? So, for example, he probably asked, if we were on moon in 1950s, 1960s, why are we still away from moon today? Right? Like, what caught into us not doing or not developing this technology further? So, A, challenging the status quo. B, his ability to vertically integrate the systems. So, for example, I know of a particular control system that goes on a satellite that literally costs you around $250,000 price point, which makes a satellite cost go up by way more, right? That guy built that entire system in-house for $600. Right. So, doing all of these things is something that makes SpaceX more special. How do you challenge this entire thing? So there's a thing in space. We don't use regular electronics in space, right? We don't use COTS or hobby grade electronics. We also don't use mill grade electronics, which is military grade. We have to use space grade electronics.
Right. So there's hobby grade, industrial grade, military grade, and space grade.
So now space grade is like the most costlier, and it is all rad hard and stuff like that. And we do that because we don't want to fail. And see, traditionally, space agencies, because it's taxpayers' money and so on and so forth, our ability to fail is like very less.
I also feel like if something blows up in space, it's such great drama that literally every news channel will cover it forever.
Absolutely. And I mean, that's the fear. That's the fear of the space agency.
Yeah.
That doesn't let them to experiment a little. And hence, a private company comes in and says, okay, I will not put a space grade electronics in space. Let me see what happens. So that guy understands the space environment a little better, brings down that space grade requirement to a COTS level, probably, in an industrial grade electronics, and still puts the same thing in space. And it works. So, the ability to kind of challenge what has been going on, I would say it's more like a fear factor, right? For example, when we preach someone, right? There's a fear factor. If you don't preach, what will happen? Something bad can happen.
Oh, for instance, when you come into CFI, which is a fabulous lab, I'm sure at a undergrad level or just first year into IIT, or at a master's level, you come and you see all this thing and you're always a little afraid that what if I blow something up, or what if I break something, or what if somebody gives me a lot of money for build this and then
you fry an IC.
Yeah.
Do whatever. Right?
which is very common, by the way.
You do it very often. Yeah. So I think that was challenged, and that keeps him very, very special. And the speed of innovation is crazy. And yes, we are going on his rocket.
Right. And of course, I want to say that I studied mechanical engineering.
Sure.
Maybe I didn't explore an engineering career that much, but to see the SpaceX rockets land vertically backwards, or to see them being caught by clippers, it was a different feeling. It was like, wow, this can really be done? Like, very inspirational moment. Okay, so of course, Elon Musk is the patron saint of space, in addition to being the patron saint of EV industries also.
Right.
Is interesting. So, and just on that thread a little bit, because we spoke so much about Hyperloop.
Yeah.
Can you explain the Hyperloop technology and what it aims to achieve?
Sure. So I think Hyperloop was thought through by Elon in around 2014, 2015 timeframe. It was a white paper by him, which literally was a feasibility study that he just wrote and, uploaded it online. And then he thought, this will trigger innovation. So he set up an entire testing facility for people to come and test their pods in a Hyperloop tube.
But what is Hyperloop?
Yeah. So Hyperloop.
No, I'll tell you why I'm asking you. I'm asking you because sometimes we do this roadshow for IIT Madras, where we go to different places and we talk to parents and students who are planning to join IIT Madras. When we talk of Hyperloop, the believability quotient goes down. Like almost the entire audience is like, what are you talking about? So can you explain Hyperloop and why it's possible even to do that?
I think Hyperloop is the fifth mode of transportation that will come up when it comes up. Right now, it's like a train inside a vacuum tube.
Okay.
It's or rather, I would say a Volvo bus inside a vacuum tube.
Okay.
And in the vacuum, it's actually floating and reaching from one point to another. And the reason why it was conceptualized was it eradicates all forms of friction. Okay. So when you move a bus, you have two major forms of friction. One is the road, the surface friction between the tires and the road surface, and the air friction, the drag. So we do vacuum, so air is gone, and we levitate, so the surface friction is gone.
Isn't it extremely expensive to do both levitation and vacuum?
It is, but when you set up a large tube or the infrastructure, once you remove one, like when you do vacuum once, then it can sustain for very, very long time. And this is about hard vacuum. You're actually doing, you're taking out air till a pressure of 1000 pascals.
Oh.
So unlike space, where you have like very minuscule pascals, you're still at 1000 pascals. So it's a soft vacuum, not a hard vacuum, so to say, right? And there'll be small leakages, of course, here and there, which you can operate small vacuum pumps and take it out all the time. I think the biggest challenge is not the technology. The biggest challenge is how do you lay down such large infrastructure? So, for example, in IIT Madras, now my team, which rolled down to 8th generation now, they have built a tube in the new campus. That's 410 to 422 meter tube. Now, 422 meter tube will test all the possible technologies that can go inside a Hyperloop.
So this is a tube that can fit a Volvo bus in it?
No, this is a subscale one. This can fit a car very easily.
Okay.
Yeah.
Nice.
Yeah. So you can possibly test everything. But then when you want to scale this up, I think the question becomes, how do you then put up an infrastructure project? You have to acquire the land, you have to get all the environment clearances, to do all those kind of things. It's not the technology that is kind of pulling it back. It's the other administrative challenges.
And is this the only Hyperloop in the world? How is it defined? Hyperloop tower? No, Hyperloop tube.
Yeah.
Is this the only Hyperloop tube in the?
It's the largest.
Okay, it's the last.
There are a bunch of them in Europe as well, but I think this is the largest. And the idea was, like when we went to SpaceX in 2019, we were the only team who put up a flag in our booth, right? The India flag. And uh, trust me, and you can go back to my team and ask whether this happened or not. But we were so pumped, and we shouted slogans of that movie Uri, like "How's the Josh? Hi sir," in front of all the teams. We were so pumped up by we being the Indian company, Indian team, and being there alone in the starting of that kind of revolutionary technology. So today, I think we stand neck to neck with all the best teams in the world.
Damn interesting. I'm just looking at your journey. It's 2025.
Yeah.
And 10 years back, you were in TCS
Yeah.
research. And then you gave gate, joined IIT Madras, heard of the SpaceX program, started a Hyperloop team.
Right.
Did that. Then moved out, joined a company, decided you wanted to get in space,
Right.
came back, started a space company. Now you're one of the hottest space startups in the country. Your satellite's launching this year with SpaceX. And that's intense. What will the next 10 years look like?
No, I think the focus is going to remain in building this entire satellite infrastructure. I think not just me, but the entire team is committed. The team of founders that I have, the support system that we have gotten, we are committed to build this entire satellite infrastructure and not just give data to India, but to the world.
Interesting. And this, what do you mean by support structure? And also, like, I want to understand the whole ecosystem that you got support from, both within IIT Madras and at a broader level.
I think IIT Madras certainly, was the center for most of these activities that I really talked about, to be honest. And this was the place where Hyperloop happened, where GalaxEye started. I met my founders. Right, most of the support system that I got outside IIT, inside IIT was all here. Right, so unparalleled support. Sometimes I would say it's an asked support. Sometimes it's a unasked support, an unsaid support that you always get. So I think being in this ecosystem, navigating you across the network, across departments, helps you build that kind of network, right? That network leads to another set of network, and then it cascades along. So, we got a first set of investors who are into deep tech. They invested in Agricul. So we got to know from them, right? A second set of investors we got to know because we had a cascaded network from space environment and so on and so forth. So I think it was always to kind of take that first step in this institute, and the rest will come along. You have to keep going. So you have to take the first step and you have to keep going, but the support will come. Support will pour in. That's my belief, right? For example, we have 5 founders. We stuck around with each other for last 8 years. We met here at IIT Madras for the first time. For 8 years, we are all together.
Fine CFI.
In Z5. When this building was not this building.
But do you feel that you'll reach a point where it'll be like, okay, you know what? This is all the support we can give. This is done.
I think then it's the point where you have to give back the support, right? So it's that circle of support system, I would say. So people see when we advance to a certain stage, we will have to give it back. For example, some of my other team members at Hyperloop have now started to build their own companies. When they walk into GalaxEye, the doors are like pretty wide open. You do whatever you want, you use whichever lab you want to use,
Right.
but build something massive. And I think that we need to have more and more.
And you've also received a lot of support from the government. I saw that you were on Man Ki Baat, which is congratulations.
Thank you.
How has that looked like? Like, did you imagine that? I don't know. Sometimes you feel from the outside. Sometimes you feel like the government is this really large machinery, doesn't care about anyone.
Yeah.
Is it really like that, or did you get a lot of? I don't know. How is it like?
I feel uh, the two nuances to that, right? I feel the person sitting on the top, who is the topmost leader, if that person is wanting to make something happen, things on the bottom gets aligned, right? And things on the bottom can be messy, can be tough to navigate at times. But then again, the second part comes in where it's a people's business, right? So you may find a secretary who is very nice to speak to you. You may find the other secretary who's very pragmatic or very conservative, right? The third secretary can be very innovative, very creative, and so it depends on person, right? Who is the person that you're going to deal with? But at large, I believe that the leadership should encourage, motivate the larger ecosystem to grow. When that is there, so there's a force field from the leadership. And in the force field, some people will fall back, some people will actually go ahead. So to pick and place with the right, pick and partner with the right people to kind of, navigate yourself. It's heavy hitting. It's not easy, but you have to navigate if you want to make things happen. And I think then the other thing is you have to also use your existing network and support system to help you kind of navigate, right? We got massive support from Professor Satya, Professor Kama, IIT Madras Incubation Cell. Uh, Beyond that, we have Gunny, who is on our board. So, our investors, Special Invest, Mela, now Infosys. All of these people, you need to kind of get your help. And you have to ask. You can't think that I'm going to be sitting back and the support will come from the front. You have to ask for it. So in 3 years, if you want to kind of,
And I'm guessing you have to smile a lot for it.
I think that's a that's the deal breaker, to be honest.
That's amazing. I want to understand when you talk of a complex engineering problem like this, there are lots of fields of engineering coming together, right? It's not just aerospace.
Yeah.
Right. So run us through, how do you build your team? What kind of people want to join companies like yours? And, what do their careers look like? What do their ambitions look like?
Right. So I think we have tried a lot of things so far. I won't still say that we have perfected it, right? But we have been very fortunate and pretty successful in building a really good team at GalaxEye. So when you start on day one or day zero, so to say, till your first few months, the kind of talent that you need is very different. Then post maybe that first milestone that you were trying to stitch through into your roadmap, the next stage needs again a very different kind of talent. And then beyond one point, you again need a very different talent, right? So playbooks at every stage changes for your talent acquisition, right? You need more generalists in the beginning, and then you go towards specialists moving forward. While having said all of these things, generalists and specialists in the space ecosystem are almost nil in this, or almost very minimal.
Yeah, there are very few. You also mentioned some 80 startups.
Yeah.
They must be all vying for the same talent.
That's right.
Plus, they have the option to go abroad and work for similar companies abroad.
Yeah. And plus, the research subjects that a lot of people that masters and PhDs do are not also aligned to what we are doing at GalaxEye, right? So I think the way we are able to solve that problem to a larger extent is by bringing a mechanism of having ex-ISRO scientists and ex-DRDO scientists becoming, so to say, as a lead of relatively fresh talent with them. Right. So, so experts coming from ISRO and DRDO who are retired, I say, sir, please come.
So you have like a mentorship layer.
Yes. So that mentorship layer bridges the gap of that experience that is non-existent in the country.
And these mentorship layer folks you have, they're still engineers at the at that age?
Yeah, I think ISRO probably still is very hardcore research till even you're 60 years of age. Management, hardly you would find, right? And people who are coming, so we've been very fortunate to get at least six to six advisors from ISRO, three from DRDO. All of these guys talk more maths than any of us.
More what?
Maths.
Max. Oh, okay. That's
They, they,
interesting.
they talk more maths than any of us put together in the team, right? For example, in an image, what is the distribution of the noise? Is it normal? Is it really? What distribution, right? We probably don't think because we are operators and we think, we can do a brute force thing and we get away. But these guys bring in that sort of experience. Say, you need to apply a fast Fourier transform. You need to do Rayleigh distribution mapping to the noise, and you need to do all of these things. See, I think a deep tech company, not just for space, for any deep tech companies, you need to be more fundamental. You need to be more first principles. And hence, you need to have that advisory layer or the mentorship layer. More than a mentorship, I would say advisory layer, who can also at times say that, okay, you're not able to solve this. Let me come to your office, with you and do, and they are literally hands-on.
That's so exciting. As an engineer, when I was studying engineering, I was so fascinated with engineering. It's so beautiful. It's all these problems, improve mankind, whatever, all of this. Then you enter your first job, and it's a crash.
Same thing.
Right? And then you realize that a lot of times you don't use too much engineering in our jobs.
Yes.
And what you're saying is deep tech companies like yours, you're sort of like, you still have that opportunity to continue going deep into engineering.
Right.
Plus you have access to mentorship of people who have done engineering, hardcore engineering for 40 years.
That's right.
Yeah, it's amazing. So has it been hard to hire talent?
I think at an early stage, you prefer more qualitative attributes to be there.
Yeah, you mean like mission aligned?
Ability to learn. I would say ability to learn, ability to listen, because an ISRO advisor who is going to come, and if you're going to oppose them, right, you need to oppose them if you feel you're right in your calculations and everything. You need to be structured. You need to structurally take those advices and structurally give them feedbacks. Right. So you need to find more attributable thought processes and ability to learn, which is more aptitude. Rather than saying, oh, have you built a radar? See, unlike in the US or Western parts of the world, where you find, oh, I'm going to build a radar. Can I go to one of those defense primes such as Lockheed Martin, Raytheon, and everyone, and get one person who's the VP of radar systems, VP of this systems and that systems? Let that guy come in, build his own team, and do the job. I think deep tech in India will see those years 10 years later.
Right.
Right now, we're all brute force.
Fair enough. We don't have a history of 50 years of deep tech entrepreneurship. Yeah, we have a history of 5 years of deep tech entrepreneurship.
Possibly. So
We have to work with what we have.
but yeah, I think it's fun, and you will see, after this first cohort of deep tech companies, we'll see more talent, solving for more niche problems, and they will be able to poach and hire from companies like us, right? Who are building those talent firsthand.
Fair enough. Your challenge will move to retaining. Yeah. I'm interested that, okay, I can see why a startup like yours will be very enticing for young engineering talent who really want to do engineering work.
Yeah.
Why is it enticing for investors? Because this sounds like a fairly risky business, right?
Yeah.
How do you convince investors to back you up?
Oh, I think it's not one way, where we say this is something that you should be investing in. I think investors are also looking at larger macro trends, right? For example, the geopolitical aspects that are, changing very often these days, and this Make in India push, building in India, and the leadership that we have today in the country. All of these things put together is making investors more excited about the deep tech opportunity or the more hardware tech opportunity moving forward. That is one macro trend, I would say. Second is the talent, right? Talent, instead of going to the US and starting a company there, they probably are now, some of them are staying back and saying, okay, I know I'm going to build a company here. So, all of these things put together, plus our history of demonstrating Hyperloop, right? A clarity on the vision that why do we want to build a satellite? It's not for the love of space, it's for a particular problem. And, we being very open to learning from the board members and investors, I think these three or four things really pulled a cohort of investors into our cap table, who we fondly call as Avengers of the deep tech.
Oh, because you're specialty.
We have Speciale, we have Infosys, we have Kavach, we have Mela Ventures, we have Idea Forge, and many. In fact, we have Zero investment from Rain Matter. Yeah. We have Prashant Petty's investment as well. Prashant Bhaiya from East My Trip.
Prashant, yeah, of course.
So all of these guys are there in the cohort.
Nice. Congratulations on what you have been able to achieve so far.
Yeah.
And I wish you all the luck for the next 1 year and 2 years. And we'll, of course, be waiting for your satellite to launch and for the first images to come in.
Yeah.
Congratulations again. And yeah, that's it. Audience, that was Suyash.
Thank you so much, Amrut, for having me here. Ask IITM is the best. Secondly, I don't know if you remember this, but IITM Entrepreneurs Group is also something, we should all give credits to. The bunch of people that come along in that WhatsApp group and discuss is also very crazy.
What Suyash is talking about is the secret underground WhatsApp group, which is meant for IITM founders to sort of rant to each other, to help each other. Which bank account should I open a bank in? How do I move Forex from here to there?
Right.
Stuff like that, boring stuff like that, which entrepreneurs need a lot of help from. Yeah, I think it's helped me a lot. Thank you, Suyash. Before I go, like, share, subscribe. Have to say this. Thank you.
With a smile.